This is our lesson on adding and subtracting mixed numbers. So pause it, get your title, your date, your learning target down, get your page set up, and then hit play and get going. So now we're going to be adding and subtracting mixed numbers together. So very quick rules, reminders from our 6th grade rules. You're going to rewrite the fractions that have a common denominator, add or subtract the fraction portion, add or subtract the whole number portion, and then put the two parts back together. Sometimes you'll have to do a little bit of simplifying or renaming when you are all done with it. Get all 4 of those steps written down, and then here's our first 2 examples. And I'm going to go relatively quickly in these because they are hopefully fairly straightforward for us. 7 2/5 plus 3 1/3. First thing I have to do is I'm going to take care of the fraction part. So I want to find a common denominator for 5s and 3s. 15 comes to mind. To get from 5 to 15, I multiply times 3, so I do the same thing up top and get 6. 3 to 15, I multiply times 5, so I do the same thing up here and get 5/15. Now I'm going to add those fraction parts together. 6 plus 5/15 is 11/15. And then remember my joke from last year, don't forget the 1st grade part of the problem. Don't forget to add your whole numbers. 7 plus 3 is 10. So we get 10 and 11/15. Here, we got some negatives. So here's my rule for you. If there's subtraction in the problem, but all the numbers are positive, I'm okay with you leaving as subtraction with their fractions. But anytime you see a negative anywhere in the problem, do not leave subtraction in the problem. You're going to get it wrong. So since our first number is negative, I'm going to change this to adding the opposite. But here's the thing, that negative applies to both the whole number and the fraction part. So make sure that negative travels with everything. So take care of the fraction parts first. I have a 7 and a 5 for denominator. Unfortunately, the only thing they have in common is 35. To get from 7 to 35, I multiply times 5, so do the same thing up top and get -20. From 5 to 35, I multiply times 7, so I do the same thing up top and get -21. -20 plus -21 is -41/35. That's an improper fraction, so I need to know how many times can 35 go into 41. It can go in 1 time, and then I would have 6/35 left over, so I have a -1 6/35. Now I go back and do the whole number part. -2 plus -5, 2 negatives, you add them together and keep the signs. That'd be -7 plus the fraction part. So now I have to add the 2 pieces together. -7 plus -1 6/35 would be -8 6/35. So these are the problems with those negatives. You're really going to have to step through it slowly. Now we're going to deal specifically with subtraction. So both numbers are positive, but we need to subtract them. And what you're going to find is sometimes the second fraction is going to be bigger than the first. So what it means is your whole numbers are going to subtract nicely. Your fraction parts aren't going to subtract nicely. What would end up happening is you'd get a positive whole number and a negative fraction, and that just doesn't work in life. They need to both be positive or both be negative in order to work together. So you never know when it's going to happen in a problem. So you always start by finding your common denominators. So I'm going to rewrite this one to have a denominator of 12 because both 3s and 4s can turn into a 12. To get from 4, I would have multiplied times 3 to get to 12, so do the same thing up top. To get from 3, I would multiply times 4 to get to 12, so do the same thing up top. And this one becomes 4 3/12 minus 2 8/12. So I can do 4 minus 2, that gives me 2, but I can't do the 3 minus 8 without going into the negatives. So here's one strategy for tackling the problem. Change everything to improper fractions. Remember to make them into an improper fraction, you do your whole number times your denominator plus your numerator. 4 times 12 is 48, plus 3 is 51/12. Same thing to your other one. 2 times 12 is 24, plus 8 is 32/12. Now you can just go ahead and do your subtraction. 51 minus 32 is 19/12. Now my last step is change my improper fraction back to a mixed number. 12 goes into 19 one time, and there would be 7 left over. 19 minus 12 leaves 7 left over. So I get 1 and 7/12. So all I did was change it to improper fractions, and then go ahead and do my subtraction. Same thing here. First step, find common denominator. So I'm going to start by writing my 7 as a fraction, 7 over 1, minus 2 and 4/9. So I want to get a common denominator for my two fractions. 1 and 9, well, I can use 9 as a common denominator. So I'm going to change my 7 over 1 into a denominator of 9. 7 times 9 is 63/9. Now I'm going to change my mixed number to an improper fraction. 2 times 9 is 18, plus 4 is 22/9. Now I'm ready to go ahead and take care of the problem. So I changed the whole number to a fraction, so I could write it with that common denominator. The second fraction we change into its improper fraction form, so that way we can do our subtraction. 63 minus 22, if you need to, you can do a little work off to the side. There's never a problem doing that off to the side, but we will get 41/9. That's an improper fraction, so we ask how many 9s can go into 41. Well, I could take 4 groups of 9. 4 groups of 9 is 36. So if I took away that 36, how much would be left over? In this case, I would be left with 5/9 left over. So that's method 1, changing it into improper fractions, doing the problem, then putting it back as a mixed number. Strategy number 2, a lot of you will remember from last year. We're going to borrow from the whole number. So for those of us who had me last year, you might remember a lot of these problems we wrote in a vertical format. 7 minus 2 and 4/9. Now the problem is we don't have any fractions to subtract away the 4/9. So just like you would in a subtraction problem, you do a little bit of borrowing. So we're going to borrow from our whole number. So we're going to borrow one of them. So the 7 became a 6. We're going to take that 1 that we borrowed and break it up into a fraction. It's got to be equal to 1. But we want it to have the same denominator as we do down here. So I would borrow 9/9. That 1 I turned into a fraction, 9/9. But now I can go ahead and subtract. 9/9 minus 4/9 is 5/9. 6 minus 2 is 4. So I get 4 and 5/9. Over here, there's a little bit more going on in the problem, so we're going to have to do some cleanup work first. We need to get a common denominator before we do anything else. 7s and 14s, well, 14 plays very nicely with both of them. So I'm going to multiply both of these times 2 to get 6 and 4/14. So I just rename this with the common denominator, minus 2 and 9/14. And now I'm ready to subtract. And again, my problem comes in is I don't have enough to subtract. I can't do 4 minus 9 without going into the negatives, which I don't want to do because my whole number part's going to be positive. All right? So we have to go borrow, just like we would in a subtraction. We borrow from the 6, so it becomes a 5. So we borrowed 1, and that 1 we're going to turn into a fraction that's equal to 1. Well, since I'm dealing in 14ths, I'm going to make it into 14/14. So just like in a subtraction problem, sometimes you have a little bit there, but you still go next door to get some more. We had 4/14. We borrowed 14 more, so now we have 18/14 over here. We want to subtract away our 9/14. Now we're finally able to do that. 18/14 minus 9/14 is 9/14. 5 minus 2 is 3. Now, we're going to practice this all together tomorrow, but I wanted you to see both of those methods. Some of you are going to be more comfortable with one, some will be more comfortable with the other, but we will practice this some more together in class. But now you've got a couple of examples to kind of fall back on.